Okay, another common application of sequence and series problems is with compound interest. And we have our general formula for compound interest, but this is not something that's given in your formula booklet anywhere. So rather than looking at that, let's instead look at our problem and see if we can use our formulas that we are given in our formula booklet. So we're saving 2,000 euros. Our bank pays 1% interest compounded annually. We leave the money and interest in the bank for 7 years. How much do we have at the end of 7 years? So let's look at, this is the start of our first year. So at the end of our first year, we're going to have 2,000 times our interest. And we do the 1 because it's 100% of the 2,000 plus the 1% interest. At the end of the second year, all of this money will have the interest applied again. So we'll have 2,000 times 1.01 squared. So we can see we've got a geometric series happening where our first term has the interest applied already, and we're looking for the 7th term. So that's going to be our first term times our first term times r to the n minus 1 power, so that's the 6th power. But that ends up being 2,000 times 1.01 to the 7th power because our interest has been applied for 7 years. So notice down here, we've got n, not n minus 1. And that's because we often look at the end of the year. So interest was applied for the first year. Now this happened annually. So we took our 1 plus our interest rate, which was 0.01 from the 1%. Let's look at what happens if we have a different compounding rate. So now we're compounding monthly. That means every year we compound 12 times. Well, our 4% interest rate is the yearly interest rate, the annual interest rate. This PA stands for per annum. So we've got our 5,000 invested for 11 years at 4% annually, compounded monthly. So if I'm compounding monthly for 11 years, that means I'm going to compound a total of 44 times. At the end of my first compound, I'll have my 5,000 times how much interest I get, but this was the annual interest rate, so I'll get 100% plus my 4%, but that gets divided by 12 because this is the annual rate and I'm doing it 12 times per year. So this is my U1. I'm compounding 44 times, so U44 is going to be 5,000 times whatever this simplifies to. Let's see. So, all right, let's turn that into a fraction. And we end up with 301 over 300. And that's going to be raised to the 44th power. So notice up here, we take our interest rate, divide by the number of times we compound per year, and then it gets raised to the number of times we compound times our number of years. So we said 44. Should we have said 44? Compounded monthly, that should not be 44. Goodness gracious. Compounding monthly means we're going to compound 12 times 11 years. So that'll be 132 is really what I should have raised this to. So we want the 132nd term because that's going to be 12 compounds over 11 years. So I can put this in my calculator. Let me just make sure that I did that mental math correctly. Thank goodness. All right, so 5,000 times my fraction raised to the 132nd power. And we end up with just over $7,757. So we'll have approximately $7,757.86 euro cents.